Today we are going to start the chapter number 21, linear symmetry. So in this session of maths, in previous session you have learned about number system, operation on whole numbers, integers, uh, linear equations, and now circle also. Now we are going to discuss about linear symmetry. So what is a symmetry exactly means? What is this words? Symmetry means, linear means that is exactly on a line. Line indicates the linear. And symmetry means when the figure is folded along dotted lines, this dotted lines. Then the two parts or parts on either side of it coincide or overlap with each other. So when the figure is folded along dotted lines, the two parts on either side of it. So here this is the figure and this is your dotted line. So this dotted line divide this figure into two parts and these two parts coincide or overlap with each other. When we are going to fold it, it will coincide with each other or overlap with each other. So this is your circle, this is your isosceles triangle. So in isosceles triangle, two of its sides are equal. So wherever two sides of this figure is equal, this line of symmetry divides this isosceles triangle into two identical parts. Okay, and just name it. This is the center row according to this line of symmetry passes through the center of a circle. This line of symmetry just passes through the AB is the line of symmetry which divides the isosceles triangle into two identical parts. So here in this figure is isosceles trapezium. In isosceles triangle, two of its sides are equal and we draw a line of symmetry or this dotted lines which divides this isosceles triangle into two equal parts or identical parts. So this one shows the symmetry of an isosceles triangle. When we are going to fold these out of this one exactly overlap or exactly coincide with each other. Same in isosceles trapezium means isosceles trapezium, this one is this side A, B, C, D, and this line of symmetry we name it as a EF. So in this isosceles trapezium, AB is parallel to CD, AB is parallel to CD and AC is equals to BD. If its non-parallel sides are equal, then we can say that this type of trapezium is your isosceles trapezium. Okay, and opposite sides are parallel and this opposite non-parallel sides are equal. So this is your isosceles trapezium, and when we are going to draw these dotted lines, and where we draw dotted lines, just between the midpoints of these parallel sides. So here from whenever we draw this dotted lines across its midpoint, it divides this trapezium into two identical parts. Okay, two identical parts. So when this figure is folded around dotted lines, the two parts are on either side of it. Either side of it means just midpoint, and here center is the midpoint for the circle. Here for isosceles triangle, wherever we have these two parts of equals of an isosceles triangle, this included angle between just the half of this will draw the we will draw the line of symmetry, and here in this one isosceles trapezium, from the midpoints we are going to draw the dotted lines. So this dotted line is known as, which divides the figure into two identical parts. This dotted line is called line of symmetry or axis of symmetry. So this dotted line is called line of symmetry or axis of symmetry. So I hope it is clear to you all, when the figure is folded along dotted lines, the two parts on either side of it, it means dotted lines coincide or overlap with each other. So this is how this line is the mirror image of each other. If we are going to hide this one and place a mirror image, it is exactly shows the half of the its part. Okay, so this dotted line is called line of symmetry or axis of symmetry. Now the next one, let's check how many lines of symmetry geometrical figures have. So this is the three figures. We show that just the mirror image of the given figure. Now, how many? This is one line of symmetry I have shown just to explain the symmetry. Now the next. Now the symmetry of geometrical figures. Symmetry of geometrical figures. So first one is line segment. So here we will draw the line segment which is having two endpoints A and B. So this is your line segment AB which is having two endpoints A and B. Now, how we will find out its line of symmetry? So, the line of symmetry of a line segment is the perpendicular bisector, or the perpendicular bisector means which bisect it into two equal parts, and this line of symmetry passes through its midpoint. So, the line segment, the line of symmetry is the perpendicular bisector of line segment AB. So what is the line of symmetry of this line segment? So this dotted line shows that or divides this line segment into two identical parts, and wherever it bisects, name it as a O, and this line as a CD. So the line of symmetry is the perpendicular bisector of line segment AB. For line segment, the line of symmetry is the perpendicular bisector of line segment AB. Now the second one is second geometrical figure is an angle. So for an angle, how we are going to draw the angle? We'll draw an angle with two rays O, A and B. So the line of symmetry of this is just the bisector of this angle. This dotted line divides this angle into two equal parts. Okay, so two equal parts, so name it as a C. So here an angle, the line of symmetry for an angle is the line of symmetry for an angle is the angle bisector is its angle bisector. So the line of symmetry for an angle is its angle bisector. So this blue line indicates a bisector of an angle AOB, and this dotted line divides this angle into two identical angles, that is AOC and BOC. Okay, so this OC is the line of symmetry for angle AOB. You can say that OC is the line of symmetry for angle AOB. So the line of symmetry for an angle is its angle bisector. OC is the line of symmetry for angle AOB. Now the next geometrical figure is scalene triangle. Third one is scalene triangle. So in this scalene triangle, first draw a scalene triangle. Scalene triangle means in that triangle all the three sides are of unequal length. All the three sides of a triangle are of unequal length. Okay, so this is the triangle ABC, and here if we are going to draw of any of its vertices a line of symmetry, the figure is not identical. Here all the three sides are of unequal length. Just take it a length as a 3 centimeter, 5 centimeter or 7 centimeter. Here all the three sides are of unequal length, so that's why we can say that there is no line of symmetry. There is no line of symmetry. In a scalene triangle, there is no line of symmetry, because if any of the vertices we are going to draw the line of symmetry or dotted line, it will not divide the figure into two identical. Two identical means two equal parts. It is not going to divide this figure into two equal parts. So that's why a scalene triangle has no line of symmetry. Now the next figure. Next figure is isosceles triangle. Isosceles triangle. So in the isosceles triangle, we are going to draw two of its sides equal in length. Here AB is equals to AC. Here AB is equals to AC. So this one, when we are going to, and always remember, wherever we have the two equal sides, so this two equal side, wherever having included angles, these two equal sides having included angle as A. So from there you have to draw the line of symmetry or axis of symmetry, which divides the angle into two equal parts. So here this line of symmetry PQ is the line of symmetry for an isosceles triangle ABC. So in isosceles triangle, you can write the line of symmetry is angle bisector of bisector between two equal sides. So here in this, so here, what is an isosceles triangle? For the linear symmetry for an isosceles triangle is the line of symmetry is angle bisector between two equal sides. So here two equal sides is AB and AC, and PQ is the dotted line which divides this isosceles triangle into two identical parts or two equal parts. So this line PQ, this dotted line PQ is called line of symmetry, and which bisect the angle between these two equal sides, that is angle A. So it is, the line of symmetry is angle bisector between two equal sides. So between two equal sides, which angle is here? Angle A. So this line of symmetry divides this angle A and divides this isosceles triangle into two equal parts. When we are going to fold this AC along AB, we get this two parts equal. It means AC is going to overlap with AB and QC is going to overlap with QB. Now the next figure is equilateral triangle. Next figure is equilateral triangle. Figure number 5 is equilateral triangle. So in equilateral triangle, all the three sides of a triangle are equal. So just draw three sides of equal length. Here all the three sides of this figure is equal. Okay, name it as a. So if all the three sides are equal, so how many line of symmetry we have in this figure? So for the equal, as you know that in a isosceles triangle, if two sides are equal, then we are going to take its between angle. So here, if we are going to take AB equals to AC, that is two sides are already equal. So we will draw the line of symmetry between these two equal sides. Okay. So between these two equal sides, I am going to draw a line of symmetry. Name it as a PQ. If we are going to take another two equal sides, AB equals to BC. I am not talking about the third side, as you have already. So here in this one equilateral triangle, I am taking these two equal sides AB and AC. Just as an isosceles triangle we had done, we are going to draw the angle bisector of between two equal sides. So here the two AB and AC, I am not talking about the side BC here. So AB and AC are two equal sides. So for that, so in this figure, so just as an isosceles triangle, I draw this one linear symmetry. Now the other two equal sides, AB is equals to BC also. So for this, we are going to draw another symmetrical line. And name it as a RS. Okay. So now we have these two linear line of symmetry. Now AC is also equals to BC. Here all three sides are equals to each other. AB is equals to BC equals to AC. So when we are taking AB equals to AC, we drawn PQ as a line of symmetry. When we take AB equals to BC, we drawn this RS as a line of symmetry. Now I am going to take BC equals to AC. So if we are going to talk about BC equals to AC, then also we are going to draw a line of symmetry which is in between the two equal sides BC and AC. So this one is the angle. So this line, name it as a TU. So in this equilateral triangle, how many line of symmetry we have? 3. So for equilateral triangle, so an equilateral triangle has three lines of symmetry. line of symmetry are the bisector of the these lines of symmetry is the bisector of angles of a equilateral triangle. So an equilateral triangle has three lines of symmetry, and this line symmetry are the bisector of angles. So in equilateral triangle, how many lines of symmetry we have? Three lines of symmetry, and this line of symmetry are the bisector of angles of an equilateral triangle. Now the next figure is a parallelogram. Because with each line of symmetry, when we are going to overlap the one of its sides to the other, then the both sides are identical. Identical means if we are going to fold along this PQ line, this AC is coincide with AB, and when we are going to fold it along this RS line of symmetry, we have the identical part AB over the BC, and when we are going to fold this linear symmetry, this figure, this AC along this line of symmetry TU, then AC is coincide with BC. Is parallelogram. Parallelogram. So in this parallelogram, A, B, C, D, each pair of opposite sides are parallel. So when we are going to draw line of symmetry over any of its sides, we didn't get the identical parts which overlap with each other. So now the next figure is rectangle. So in rectangle, how many lines of symmetry we have? So for in rectangle, how many sides are there? 4 sides. Where opposite So how many lines of symmetry we have? In this one, we are having 2 lines of symmetry, which is passes through the midpoints of opposite side of a rectangle. So when we have to draw the first line of symmetry parallel to AB and CD, parallel along. So here through its midpoint we are going to draw the line of symmetry. This is your vertical line of symmetry. Now other one, from the other 2 sides midpoint, we are going to draw the other line of symmetry. Name it as a EF and GH. So here GH is your vertical line of symmetry, this GH, vertical line of symmetry, or you can write it as a vertical axis of symmetry as the place of line, and here EF is horizontal line of symmetry. So in rectangle, how we are going to draw the line of symmetry, which is just the midpoint of the, which is just passes through the midpoint of the opposite sides of rectangle. So here GH passes through the midpoint of side CD and AB respectively, and here E and EF line of symmetry passes through the midpoints of AD and BC respectively. So a rectangle has two lines of symmetry. So rectangle has, it has two lines of symmetry, and where we are going to draw the line of symmetry of the rectangle, these are the line joining the line joining the midpoints of the opposite sides of a rectangle. So rectangle has two lines of symmetry, and these are the line joining the, this line joining the midpoints of opposite sides of a rectangle. So the next figure is square. So rectangle has two lines of symmetry. Now the next one is square. Next one figure is figure number 8, square. So in this square, as you all know, you have already learned about this square, that square has also four sides, but all these four sides are equal in length. So just draw the square in which we are having the all the four sides are equal in length. Here all the four sides are equal in length. Name it as a P, Q, R, S. Okay. So how many lines of symmetry this square has? So for that, first you all know that just as a rectangle, here also we are going to draw the line of symmetry which passes through the midpoints of the opposite sides of a square. So draw one vertical line, other one from the midpoints of the other two sides, and here when we are going to fold along these lines of symmetry, we have the identical parts of these two parts. Okay, this midpoints divides this figure into two identical parts, from along vertical line of symmetry also and along horizontal line of symmetry. But when we are going to draw the line of symmetry along its diagonal, then also we get the same identical. When we are going to fold along its diagonal, this part is going to overlap with this one part. Okay, so one line of symmetry and the other line of symmetry from this. So here, just name this line of symmetry A, B, C, D, E, F and G, H. So how many lines of symmetry we have here? And all this line of symmetry passes through one identical point here, name it as a O. Two lines of symmetry, one vertical from the midpoint of the opposite sides of a square, and here also other two, one horizontal line of symmetry, and these other two are passes through the diagonal of a square. The square has four lines of symmetry, and these are the diagonals, and four lines of symmetry is where we will get the four line of symmetry. These are the diagonals. These are the diagonals and the midpoints of opposite side of a square. So square has two diagonals, so two line of symmetry forms on a diagonal, and opposite side we have two line of symmetry, one is vertical and other one is horizontal. So square has four line of symmetry, two are the diagonals, two lines of symmetry we from the diagonals and two from the midpoints of opposite side. So how many symmetry a square has? 4. Now after a square, a rhombus. Ninth figure is a rhombus. A rhombus. So for rhombus, you can say that in rhombus also all its four sides are equal in length. So rhombus is said to be a one of its properties same as a square, that all its four sides are equal. Square is said to be a rhombus, but rhombus is not said to be a square, because in a square all its four angles forms a 90 degree. But here opposite angles are equal, and all these four angles are not equals to 90 degrees. So that's why a square is said to be a rhombus, but rhombus need not to be a square. So in this rhombus, how many lines of symmetry we have? Because when we are going to draw along its midpoint, we are not going to have a line of identical parts. So for that, here we have the line of symmetry along its diagonal. So this other two parts, these diagonals of a rhombus divide this figure into four identical parts. First one is along the PC, two identical parts we have along this, and from this RS line of symmetry we have other two identical. So in this rhombus we have, it has two of symmetry. It has two lines of symmetry, and where it forms, and this line symmetry, these are the diagonals of this line of symmetry. These are the diagonals of a rhombus. These are the diagonals of a rhombus. So rhombus has a two lines of symmetry which passes through the diagonals of a rhombus, or which forms through the diagonal of a rhombus. Now the next one is kite. 10th figure is your kite. So the 10th figure is kite. So in a kite, two of its adjacent sides are equal. Two of its adjacent sides are equal. Two of adjacent side means these two sides. Name it P, Q, R, S. In cyclic order I have written the name P, Q, R, S. And kite, in kite, if you have to define the kite we are having adjacent sides are equal. It means PQ equals to PS and QR equals to RS. So here we are having the opposite sides, adjacent sides equal in length. So to draw its line of symmetry, which passes through the diagonal, one of its diagonal, that is vertical line of symmetry. When we are going to draw the horizontal diagonal, this line of symmetry doesn't divide this figure into two identical parts. So that's why we are going to draw the line of symmetry along this one. So the line of symmetry along this vertical line of symmetry, horizontal line of symmetry is not possible in this one, because when we are going to draw this one and when we are going to fold along this one, these two parts, this part is not identical to this one. So that's why we have only one line of symmetry in a kite. One line of symmetry, because when we are going to fold this part to the other one, it is identical to each other or coincide with each other. So here PSR triangle overlap with the PQR triangle. Okay, so this line of symmetry, name it as A, B. So this AB line of symmetry divides the kite into two identical parts. So kite has one line of symmetry. It has one line of symmetry. And you can say that it has one line of symmetry, namely diagonal AB. What name I have given to this symmetry as, namely diagonal, this one diagonal AB of kite PQRS. So it has one line of symmetry, namely diagonal AB of kite PQRS. So kite has one line of symmetry. Now the next figure is isosceles trapezium. And isosceles trapezium. In the beginning only I had explained you what is an isosceles trapezium. So here we are going to draw the trapezium where we have two opposite parallel sides which is non-equal in length and non-parallel sides which are unequal in length. So these two sides are equal in length. So here for this figure, this non-parallel sides equal. So when we are going to draw the line of symmetry which is passes through the midpoints of opposite sides, opposite parallel sides, which passes through the midpoints of opposite parallel sides. When we are going to overlap these parts to this one, it overlap exactly or coincide exactly to each other. So that's why this line of symmetry, this vertical line of symmetry, name it as a PQ. So this PQ divides the isosceles trapezium into two identical parts, and these parts exactly overlap with each other. So isosceles trapezium, it has how many lines of symmetry? One line of symmetry. It has one line of symmetry. This is joining. This is the line joining the midpoints of the midpoints of opposite parallel sides. So here PQ is the line of symmetry for an isosceles trapezium ABCD. Now the next figure is a semicircle. Next figure is a semicircle. Semicircle means just half of the circle. This is center O, and here it is AB is the diameter of a semicircle. So semicircle, the line of symmetry divides this semicircle into two identical parts, so that divides the perpendicular bisector which passes through the center of the circle. So here this line of symmetry, name it as a PQ, is divides the semicircle into two identical parts. Here this part POB just overlap over POA. So this PQ is your line of symmetry which is the perpendicular bisector of diameter AB, which is the perpendicular bisector of diameter AB. Perpendicular bisector means divides into two equal parts. It means OA is equals to OB, and here perpendicular means this one will make 90 degree. It means AOB is a straight line. Now the semicircle, how many line of symmetry it has? You will write a semicircle has one line of symmetry and it is perpendicular bisector of diameter AB. So a semicircle, it has one line of symmetry and it is a perpendicular bisector of diameter AB. Now the next figure is a circle. This is the last symmetry for class 6. This is the last symmetry of geometrical figures, that is circle. Last one, 13th one, a circle. And name the center as a O. So how many lines of symmetry a circle have? So a circle has infinite lines of symmetry, because when we are going to draw a line of symmetry which passes through its center, we have infinite line of symmetry because it divides the circle into so many identical parts. We have, when we are talking about the vertical line of symmetry, it divides the circle into two identical parts. When we are going to draw horizontal line of symmetry, it also divides the circle into two identical parts. Other horizontal line of symmetry, that also divides the circle into two identical. So you can write a circle, how many lines of symmetry? It has infinite of symmetry passes through the center of a circle. So just recall whatever we have learned today. Line segment, a line segment has one line of symmetry. Next, an angle, it has also a one line of symmetry. A isosceles triangle has one line of symmetry. Equilateral triangle has two line of symmetry. So isosceles triangle has one line of symmetry. Equilateral triangle has three lines of symmetry, and parallelogram has no line of symmetry. Next one, rectangle has two line of symmetry. Square has four line of symmetry, and rhombus two lines of symmetry along its diagonal, and kite has one line of symmetry, and an isosceles trapezium has also one line of symmetry. Semicircle is also having a one line of symmetry, and a circle is having infinite number of lines of symmetry. So that's all for today. In next turn we will learn about the symmetry of an English alphabet. Okay, that's all for today. Just revise it. We will start after completion of this letter symmetry of English alphabet. We are going to start the exercise. So that one, this all we will do on the next session of this class. Thank you.